This is Mike Bossy for Team Pew Cubed, showing our current status as of Sunday, November 20th at 7 p.m. This is the Reds robot. Everything's on the breadboard. We're going to keep it on the breadboard until we have everything working reasonably well. Everything working perfectly from a hardware standpoint and reasonably well with software. We can always update software. This is the Arduino and really the guts of the assembly. Arduino does the majority of the processing for us. This is the wireless communications for the Arduino. This is the business end of the system. So we have our dazzler here, our red confirmation laser here, our red illumination LED, and there's an IR illuminator in there as well. We keep it covered because it's not super eye safe. And that is the Raspberry Pi no IR camera. There's a whole pan tilt module, pan motor, tilt motor. This is the Raspberry Pi. Really all the Raspberry Pi does is provide a video stream and do the image processing. It's much easier to work with the Arduino, so that does the majority of the system control. This is the base for the physical assembly. Keep in mind, mechanical goals were not part of our design goals. So it's a little bigger than you would expect, but it proves our concept. There are wings that go on it. They attach here and they close it up. Those are being painted camouflage right now. This is the remote. So this is what our final remote will look like. We got to make some small tweaks to the enclosure here so it'll fit on the rifle / Nerf gun we're going to use. This has the wireless communications here, same on the Arduino end, and then the Arduino communicates the instructions back to the Raspberry Pi. Ended up being a lot easier for us to work with. These are our mode selection buttons, our IR laser, our red laser, dazzler control, and then these are recent additions that aren't reflected in the technical readiness review slides. This is the home position seeker, and this is the robot red laser. We use the home position in case the system gets confused. With our current image processing, that tends to happen if it turns too far in one direction where there's a lot of motion. It'll get confused, so we have to press that button to return it to home and correct the issues. Right now, I'm going to demonstrate our simpler modes. So the remote is on, software is running on the Raspberry Pi. This is just the standby mode. Power is applied. We're using the bench power supply. Our battery's actually right here, but it's kind of a pain to hook up. We've confirmed everything works just fine off the battery. Alright, so we're in standby mode. I'm going to switch it to escalation mode, otherwise known as manual control mode. And then using this joystick, I will control the system as if it were a remote camera. I can also activate the dazzler, simple light, and the pulse mode. I'll activate the red laser, so red laser is now on. And then the red LED there is just our illumination LED. It's assumed that whenever the operator is in escalation or manual control mode, they'll want illumination. Finalized design wouldn't have to have a red LED. It'd probably both be infrared, but it's a lot easier for us to use having one red LED on there. Alright, return to standby mode. And the system is now in automatic surveillance mode. So this is where it's behaving as if it were a independent security camera. So it's going to automatically pan and tilt. So we used 180-degree servos, and what will happen when it reaches the end of its 180-degree range is it will flip. If it doesn't, okay. So that gives us the effect of a 360-degree system. The software automatically flips the image to compensate for this. Alright, put it back in standby mode, and then home position. I will show the image processing. It still has a lot of bugs, so you'll see that in a separate video. I don't want to have to mess up this video because our image processing embarrassed me.